So dear students, we were dealing with dielectric and polarization, and so in the last class, okay, we did, after dielectric and polarization, we did uh, capacitors. We did an introductory video for capacitors. So capacitors were basically, I want to review, the relation that we have taught in the last class. So capacitor was the combination of two charged conductors, one positive charge and another one negative charge. It is a system of two charged conductors separated by some distance d. And in this case, what we saw was the charge on this capacitor was directly proportional to the potential difference between the two conductors, because as the charge in this conductor increases, the positive potential increases, and even if the charge here, negative charge here, increases, the negative potential increases, such that the potential difference also increases. So Q was directly proportional to V. This gave us Q is equals to CV, where C was a constant and it was known as the capacitance of the capacitor, or capacitor is the system, so it is the capacitance of this system, or simply the capacitor. So this is a capacitor. Now what things that C depends on? So this capacitance of a capacitor depends upon the area of the conductor. It directly depends upon the area exposed, like the area of this system of conductor, and the separation between the conductor, and third one, the nature of the medium. This is the nature of the medium separating the conductors. Nature of the medium separating the conductors. So it also depends upon the what is the nature, what is this medium which separates the two conductors. Either it is air or dielectric or even conductor. So what is this medium? So it depends upon that medium, nature of the medium separating the two conductors. Okay, so this was our capacitor. So in this capacitor we want to do furthermore, and that is, so the capacitance of the capacitor, which is Q is equals to CV, can alternatively can be written as C is equals to Q by V. So is that its unit will be the unit of the capacitance will be charge. Unit of charge, that is coulomb, and unit of voltage, potential difference, that is volt. So unit of capacitance is coulomb by volt, or it is known as farad. After the name of the great scientist Michael Faraday. And farad can be denoted as F, capital F. So 1 farad is 1 coulomb divided by 1 volt. 1 farad is 1 coulomb by 1 volt, or 1 farad can also be written as coulomb, 1 coulomb, volt inverse. So unit of capacitance is farad, and 1 farad is coulomb volt inverse 1. Now, the symbolically in a circuit, capacitance can be represented as this. So symbol of the capacitance is this. Symbol of capacitance is this. And symbol of variable capacitance. Variable capacitance means the value of the capacitance can be varied. So this is variable capacitance, capacitor, variable capacitor. This is simply a capacitor, So symbolically, capacitor can be written as this one, and unit of capacitance is farad, which is denoted by capital F. Now let us draw a capacitor again. So this is a capacitor. It is a system of two conductors separated by some distance d, and there is a medium separating the two conductors. So if you saw closely, here is an electric field directed from positive charge to the negative charge. Okay, here is an electric field directed from positive to negative charge. So what this electric field do is, this electric field tries to flow, or simply, in other words, we can say it tries to break down the, if this is some medium, so it tries to break down this medium. If the value of the electric field will be more, it breaks down the medium separating the two conductors. So how it breaks down? It allows the positive charge of the medium to flow along the electric field, and it allows the negative charge in this medium to flow against the electric field. Then what will happen? This dielectric or this medium will breaks down. So the strength of the medium, okay, in other words, I can say the maximum electric field this medium can persist, because this electric field tries to breaks down this medium by separating the two charges. So the maximum electric field this medium can persist, the medium between the two conductors can persist, is known as its dielectric strength. Okay, so the maximum electric field, this medium separating the two conductors can persist is known as dielectric strength. Its dielectric strength. So the maximum electric field this medium separating the two conductors can persist is known as its dielectric strength. Suppose this medium separating the two conductors is, let us take it, if it is suppose air. Suppose it is air. If the medium separating the two conductor is air, let us take it is air, then its dielectric strength is, the dielectric strength for air is strength for air is 3 into 10 to the power 6 volt per meter. So dielectric strength for air is 3 into 10 to the power 6 voltmeter. What is this? This is the value of the maximum electric field. This is the value of the maximum electric field this medium air can persist. If in this air the value of the electric field crosses this value, then what will happen? The molecules or the atoms of the air separates in positive and negative charge. Hence, the medium breaks down. So, if the medium separating the two conductors in a capacitor is air, then the value of the electric field must be lesser than this value. Okay. So, if this is the value of the electric field, or the value of the dielectric strength is 3 into 10 to the power 6 volt per meter for air, then what is the potential difference between the two conductors in that case? So simply we have potential difference as del E. So we have derived the relation between potential and electric field. So potential difference V is del E by del S or del R, something like that, del R, del E by del R. So potential is basically electric field divided by distance, del E by del R. So E is electric field, del R is the distance. So potential difference is electric field divided by distance. Suppose this distance separating the two conductors is, let us take 1 centimeter. If distance is 1 centimeter, then your D will be 1 centimeter, or simply 1 centimeter is 10 to the power 2 meter. Then potential difference will be simply, it is ED. Potential difference is, we had relation electric field as del V by del R. Del V by del R. So electric field is potential divided by distance. That means potential will be electric field into distance. This is wrong. So electric field is del V by del R, or simply electric field is potential divided by distance. Potential divided by distance. So potential is electric field into distance. So potential is electric field 3 into 10 to the power 6 into distance is 10 to the power minus 2. So your potential difference will be 3 into 10 to the power 4 volt. Okay, that means air, for an air, it can act for an air so that it can act as a medium separating two conductors in a capacitor. Then the potential difference between the conductors must be less than this value, 3 into 10 to the power 4 volt. If the potential difference between the two conductors, increases from this value, that is 3 into 10 to the power 4 volt, then what will happen? It will exceed the dielectric strength of the air. Dielectric strength of the air, and then the air medium will break down above this voltage, that is 3 into 10 to the power 4 volt. So what is the solution for it? The solution for it will be, because we don't want to break the medium separating the two conductors, now its solution will be, we have capacitance is equals to charge divided by V. So what we will do in that case is, if we want to operate this parallel plate this capacitor, we want to operate this capacitor without breaking its dielectric strength, So what we'll do? We will increase the value of the C. So when you increase the value of C, then what will happen? If you increase the value of C, then Q increases. So if Q increases, Since the value of C is more, your V decreases. Your V will be small. Okay. So Q increases, but Q increases with the increase of C. Okay, you are increasing the charge stored in the conductor. This Q is simply the charge stored in the conductors. So you are increasing the charge stored in the conductor simply by increasing the value of the capacitance. So when you increase the value of the capacitance, your V remains the same or V decreases. So if V decreases, then you can easily operate this capacitor below its dielectric strength. So this is the trick to utilize capacitors such that it can store more charges at relatively less potential. So the idea is to increase the value of the C. So this is it for today. Thank you.